This video introduces structures and cell arrays, useful for representing information that contains heterogeneous data of different types or sizes. If you'd like to represent a collection of different pieces of information that could be of different types and sizes that you'd like to refer to by name, then you should use a structure. For example, let's say you wanted to store the different attributes of a car, such as the year, color, and miles per gallon. With structures, the different attributes are known as fields, and you use what is known as dot notation to assign values to them. The structure car with field year equals 2009. Structures are displayed in this way, listing the values of each field. Car.color equals red. Car.miles per gallon equals 35. Fields can contain any class or different size of data array, even another structure. You access values with dot notation too. Here we see car is of class struct. You can also inspect a structure in the variable editor. An alternative way to create a structure, specifying all fields at once, is with the struct command. You can specify pairs of field names and values. This command also lets you create structures if you have the values stored in a cell array. Like other MATLAB data classes, you can work with structure arrays. You can use concatenation. The default display of structure arrays just lists the field names and not the values. And you can use indexing. Here we will assign a value to the miles per gallon field of structure element 2, then display the entire structure to see the updated value. You can access a particular field of all array elements in this way. Note that this returns multiple separate values. This is called a comma-separated list, which is what you get if you enter any list of values separated by commas. Comma-separated lists can't be assigned to a single variable, but can be passed as arguments to a function. To find out more about using structures, see the documentation under Programming Fundamentals. If you have heterogeneous data of different sizes and types, but you'd like to access it all as an array, then a cell array is the most convenient class. You use curly brackets to construct a cell array. For example, in my cell, we will include numerical scalars, a string, a vector, and a logical value. Information from spreadsheets are often best stored as a cell array, and cell arrays of strings are a common way to store lists of textual data. You can work with cell arrays just like other arrays, such as with indexing and concatenation. Indexing with parentheses returns another cell. Here we will use the class function to see what class Y belongs to. A cell array is returned as the elements of the subarray could also be of different types. Indexing with curly brackets accesses the actual values. Here we see Y is now a character array. When working with cell arrays, make sure you use the correct brackets for the type of access you want. Note that accessing multiple values with curly brackets returns a comma-separated list. Although, as mentioned before, the list elements cannot be directly assigned to a single variable, they can be grouped back into a cell by using curly brackets. To find out more about working with cell arrays, see the documentation. That concludes the demonstration. You can try these features in MATLAB now, or watch one of the other videos.